Hi and welcome everyone to our last and final module for this year's cycle, CCNA Routing and Switching Curriculum, Scaling Networks, version 6.0. Again, this is Engineer Ernely E. Pineda, your instructor. And today we're going to talk about one of the best and widely used dynamic routing protocol, the Ospf, or short for Open Shortest Path First. Now, since we are already done discussing the theories, backgrounds, characteristics, and differences of dynamic routing protocol from our previous modules, this time we are going straight with the implementation and configuration proper. First, for single area Ospf, that is version 2, which is used for IPv4 networks. And later on, the implementation of the same protocol, Ospf, but this time it's version 3, which is used for IPv6 networks. Alright, so we're gonna do both single area Ospf for IPv4 and IPv6 networks. Alright, so without further ado, let's get to it. Alright, so first, before we proceed with the configuration proper, let's take a look at the at this module's objectives first. So I was saying a while ago, we're gonna try and implement single area Ospf version 2 for IPv4 networks, right? One of its parameters is configuring an Ospf router ID. Okay, so this will be like this comparison with EIGRP, since you already know how to configure EIGRP, okay, the characteristics of EIGRP, and the dynamic routing protocol that was discussed from previous chapters or modules. So this time we're just gonna go straight. Since you already understand what router IDs are used for. Okay, so we're gonna configure that this time using Ospf. Okay, next we're gonna configure the single area. Okay, so I was saying a while ago, then we're going to verify if our sample network topology is fully converged by testing and verifying if the Ospf is running properly, okay, on your network. Alright, next is the last part will be the implementation of single area Ospf, but this time it's going to be the version 3. Alright, so as we all know, version 3 is used for IPv6 only network. Okay, so using this module, or with this module discussions, okay, you can learn how to compare, okay, the characteristics and operations of both of Ospf version 2 from Ospf version 3. So we're just gonna see the difference in terms of the implementation, the operation, and the configuration proper. But overall, okay, it's still the same protocol. Okay, it's still Ospf. Okay, they just differ in terms of the network type, since version 2 works for version for IPv4 and version 3 works for V6 network. And then at the same time, we're gonna try and configure, at the same time verify also if your Ospf implementation single area for version 3 works. Okay, so this will be the coverage of this module. Alright? Okay, so we are now on this sample topology that we're gonna use, okay, to run and implement first single area Ospf version 2. Okay, so as you notice, okay, we have here an IPv4 network, so it is a 3 router setup, okay, R1, R2, R3, okay, with the following network implementations. Okay, so the network addresses, okay, the initial configuration of each interfaces of all routers are already pre-configured in this sample activity. Alright, so what we're gonna do here is we're just gonna run and implement single area Ospf, okay, to converge our network. Okay, converge means, okay, as we discussed from previous modules, no? So that all of the hosts, okay, PC1, PC2, PC3 can be able to reach each other. Okay, that means reaching their local networks and their remote networks. All right, so as you notice, we have this big circle here in the middle. So it means we're just going to implement single area, okay, for this network topology. All right, so we're going to run single area OSPF version 2 for IPv4 network. All right, so let's take a look at our task. All right, so these are the initial tasks that we need to set. Okay, first, all right, so we're gonna run OSPF on all routers. Okay, and then we're gonna use process ID number 10. All right, and then we're gonna use OSPF area number 0. Okay, now as we discussed from previous modules, now when you say process ID, okay, we're gonna go to the configurations later. Let me just discuss what process ID first. Okay, it is a global configuration command, okay, that represents a number. Okay, you can use process ID, you can use numbers between 1 to 65,535. Okay, so it's up for the network administrator to set the process ID. All right, and at the same time, when you say process ID, it is not locally significant. Okay, which means you can use different process IDs for each of these router. Okay, they will still establish network communication even if they have different process ID. Okay, so it's a bit different with EIGRP implementation, right? So in OSPF, okay, you can use different process IDs in each router since it is not locally significant. All right, so it doesn't need to have the same value. Okay, but okay, since for simplicity, no, for network simplicity, and so as not to confuse network administrators or your users, probably if there will be someone to, let's say, configure, all right, these routers in the future, no, might as well use the same process ID, use just one process ID for all routers. Okay, so it will not have any impact or problem with the network, even if you use the same process ID or not. All right, so we're going to use 10 for this activity or for this example. All right. All right, so moving on with the actual configuration. Okay, let's start off. Let's begin with router 1. Okay, so let me just check on router 1. So I mentioned a while ago that this network topology is already pre-configured. So it means all of the values here, IP addresses, interfaces are already up and running. The IP addresses are already pre-configured. Okay, the network addresses are already declared. Okay, as you can see on these tables right here. All right, but by just visually checking the topology, okay, and implementing the one that you've learned in terms of counting the number of remote and directly connected networks. So in R1, obviously we have 3 directly connected networks. Okay, I'm just gonna make this one fast, no? Directly connected network means, okay, they have physical connection with R1. So those are 1610, 1630, and 1610, 1630, and 168.10.4 networks. All right. So also from this given topology, okay, we can see that from 3 directly connected networks, we also have 3 remote networks. Okay, those are the networks that are not physically connected to R1. So we have this network right here. All right. We also have this network right here and this one right here. So 3 remote networks from R1. Okay. So what we're gonna do is we're gonna run OSPF so that all of these routers can be able to communicate with each other. Okay, build adjacency using OSPF, and then later on advertise their networks to each other so that we can achieve network convergence. Okay, and we can reach those remote networks. So first up, okay, let me check if we have already configured IP addresses and they are up and running. So I'm just going to show IP interface brief. So as you notice, no, we already have pre-configured IP addresses. They are up and running. Okay, so I think we can just move on, okay, with the actual OSPF configuration. All right, so first up, okay, what we're gonna do is we're going to enable OSPF using process ID 10 on each router. So I'm at R1 right now. So I'm at privilege mode. I'm gonna go to global configuration mode. So config T global. All right, and then I'm gonna run router. Okay, space. If you're gonna put question mark there, it will show you the different available, no, dynamic routing protocol that you can use. All right. So we already use EIGRP from previous modules. We use already the old grip. Okay, this time I'm gonna use OSPF. It's that one right there. Okay. So I'm just gonna type in here OSPF. Okay, space. Okay, if you put question mark again, it will ask you for process ID. So this is the one that I'm mentioning a while ago. So you can use process ID from ranging from 1 to 65,535. Okay, so this time we're just going to follow the parameters that is set on this task requirement. So it says here we're going to use process ID number 10 on all routers. So I'm just going to put that there. So that's it, no? Enter. Okay. All right. So once you are inside, all right, the prompt. Okay, so config router, if you change the config router, it means you are already inside OSPF 10 prompt. Okay, let me just look at the different commands that are available inside this prompt, inside this router OSPF prompt. So we have here the area, auto cost bandwidth, okay, the rest of the configurations right there. You have the passive interface. So it's just the same commands that we are seeing, okay, from the IGRP implementation last time. Huh? We're going to use network as well to declare, okay, later. All right, we have also the negation command. All right, the redistribute command is also there. And what do you notice? So we also have the router ID right there, right? So it's basically the same, no, set of commands that we found or that we can find in EIGRP. Okay, but this time, since we are running OSPF, it has different all right, it has different algorithm in terms of its usage. It uses link state, all right, link state, compared with EIGRP, that is distance vector, a partial link state. But this time, OSPF is pure link state type of dynamic routing protocol. Okay, so let's just go ahead and change the router ID first before we declare networks. So I'm just gonna change the router ID here, a router dash ID. For R1, let's just make it simple, no? Just choose 1.1.1.1. Okay, for R1. So we're still using the same IPv4 format for router IDs. Same concept with EIGRP. Alright, so enter. Okay, so that is okay. And then next. Alright, I think we're about ready to declare our networks. Alright, so let's take a look at our topology. So when you declare network, okay, again, we are declaring the ones that are directly connected to R1. So that's why it's very important for you to identify those network addresses initially, no, before you implement OSPF config. No, identify the directly connected networks because those networks are the one that you're going to declare inside the router OSPF. Alright, so let's start off with the first network right here on the LAN, 172.1.1.0/24. So I'm just gonna run network, and then I'm gonna declare that 172.1.1.0 space. Alright, so if you put question mark here, okay, to see what's the next parameter that you're going to fill up, alright, it says there that you will need to provide the wildcard mask. Alright, so sounds familiar, right? So it's just the same approach with the EIGRP. Alright, so the computation of the wildcard mask will also be recalled on this module. Alright, so we're not going to go through that. So I'm just going to make it faster since We already discussed that in the previous module, how to compute for the wildcard mask. So just by looking at the subnet mask, the opposite of it, that is the wildcard mask. So /24, that means the subnet mask is 255.255.255.0. Okay, if you reverse that, it's going to be 000.255. Alright, so that is a network declaration. Okay, but this time in OSPF, okay, aside from the network declaration, okay, when you put question mark here, okay, the syntax doesn't end there. Alright, OSPF will ask for the area number. Alright, so what area are you going to use in order for these routers that are involved in the OSPF exchange, okay, can be able to communicate with. Alright, so I'm just going to put area command there. So since we're using single area, we're just going to use one area number for all routers. Okay, or for each router. So we're just going to declare one area number. Okay, that goes to single area OSPF. Alright, so in our task requirement, we are asked to use area 0. Alright, so maybe if you're wondering what are the range of area numbers, okay, so here it is, no? It's from 0 up to this number right there. Okay, in terms of decimal number. Okay, so you can use that. You can also use IP address format. Okay, but just to make it simple, we're just going to use the decimal value. Okay, so 0, area 0. So that is our one network declaration. Okay, it doesn't end there because as I've said a while ago, we need to declare all directly connected networks. So we're done with this part right here. So how many networks do we still need to declare? 2. Alright, correct. So I'm just going to type in again, network. The next network address is 172.168.3.0. Okay, /30. That means the subnet mask is 252. So if you reverse that, okay, 255 minus 252, that only leaves you .3. Okay, then area 0 as well. Okay, just gonna enter this one. The last network declaration. Alright, 192.168.10.4. Okay, /30 also. So we're just gonna use the same subnet mask of 0.0.0.3 and area 0 declaration as well. Alright, so we have 3 network declarations for R1. Do we need to enter more? No. Alright, because those are just the directly connected networks inside R1. Okay, so we're done with the network declaration. Okay, we're good. Alright, so just look at the parameters. Let's see. So we're done with number 3, number 2, number 1. So the last class that we need to set is to declare passive interfaces. Okay, so again, no, passive interfaces was discussed. Passive interface command was discussed in the previous module. Okay, the purpose of passive interface is that you are blocking you are selecting the interface to block, so that that router will not send, okay, any OSPF update out of that router, since it will not be used, okay, by different network devices that is connected to that link. So in this case, we're just going to declare passive the LAN link. Okay, this one right here. So to check which LAN link ID is being used, okay, I'm just going to go back to my show IP interface BR and then look at the LAN link that is being used by this port right here. Okay, the one that has the IP address and active. So that is one right there. That is G0/0 because it has an IP address. Okay, in this case, it only has one, so I don't need to bother looking at the other interface. Okay, and at the same time, you will notice that the IP address right there belongs to that network. Okay, indicated on the label. So I'm just going to declare that passive. So passive interface, that is G0/0. Okay, so I'm just gonna put enter here. Alright, so that is all good. Okay, that is the process. Simply how to set the basic OSPF single area declaration. Okay, so this is for R1. Okay, so that is just the procedure in terms of the task. You just followed it. So basically that is all. Alright, so what we do, okay, I'm just gonna go and click enter end to go back to privilege mode. I'm just gonna run, save the configuration. Alright, then we're done with our one. Okay, so I'm just gonna close it here. Later we're just gonna use the different show commands uh, to check if our configurations or if our configurations are accepted and if you have good values and non-missing or uh, no errors in terms of your inputs, particularly in the network declaration. Okay, so I'm gonna proceed with R2. Okay, do the same configuration. Enable, configure terminal, global mode. Okay, so I'm just gonna repeat the same process that we did with R1. Okay, so it's just basically the same, identical configuration. Okay, except for the network value declaration. Alright, so I'm gonna go with R2. Alright, so global mode. So I'm just gonna enter router OSPF. The process ID is 10. Okay, inside R2, we're gonna declare router ID this time. Okay, so we used 1.1.1 in R1, so I'm just gonna use 2.2.2 here in an IPv4 format. Okay, then after that, okay, we are set to declare our network. So let me just move this one a bit to see the network topology so that I will know what are the networks that I need to declare on R2. So again, the directly connected networks on R2 are these networks right here, 16.20, 16.30, and 192.168.10.8. So I'm just gonna declare all of those networks. So 3 networks in total. So network, I'm gonna start off with 172.16.2.0, subnet mask of /24. Okay, so by now you should be faster, no, in terms of calculating the wildcard mask by just looking at the subnet mask. All right, and then area 0. So you notice now we're using the same area number, okay, as was as declared in R1, since this is just a single area OSPF implementation. Okay, so we have that. Okay, I'm just gonna press up arrow key here, and then I'm just gonna change the values to declare this network right here, 3.0. Same, no, the subnet, the wildcard mask is /30, so I'm gonna use .3. All right, area 0 is just the same. Okay, enter. All right. Next, maybe you're wondering, no, what if, for example, let's say I mistakenly input or entered a wrong network address number. So what can I do? So in that case, all you have to do is to go back to the one that you entered previously by using your up arrow key. Okay, up arrow, down arrow in your keyboard. So for example, if I'm going to remove this network right here, all you have to do is to put no in the beginning. Okay, so no network. All right, and then the network address that you wanted to remove or replaced with correct value. All right, just in case you pressed the wrong number. Okay, or you computed for a wrong subnet or wildcard mask. All right, so just put no in the beginning, and then just press enter. Okay, so I'm just not gonna do that here. Next, I'm gonna declare the next network. Alright, 192.168.10.8 network. So I'm just gonna go here and replace that. So that is 192.168.10.8 network. So that is /30. It means we have 0.0.0.3. Okay. By the way, you notice this message while we are talking about the network declaration. I didn't type this message right here. It just popped out from the config. So what does that mean? So it's just the same principle with the IGRP implementation. While you are doing the IGRP configuration commands, once routers establish adjacency from each other, it means you configure the correct OSPF parameters. Okay, they will negotiate and establish network adjacency. So this time right here, I think this bridge here, or this adjacency, was declared or was achieved by R1 and R2. Since I already done configuring R1 running OSPF, alright, so the moment I entered R2 parameters, okay, that will link R1 to R2, okay, this message pops out. Alright, so as you can see, no, right there. Okay, so the bridge to 1.1.1.1, that is R1, has already been created, okay, using process ID number 10. So yeah, we're not done with the config, so do not be confused. This pop-up message, don't mind that, it's just normal. You proceed with the network declaration. So I'm done declaring two networks. Okay, I'm about to enter the last network declaration. So I'm just gonna make sure that the values are correct, and that 8/30, that gives you 0003, while port mask area 0 as well. So enter. Okay. Next, I'm gonna declare the passive interface. Okay, but I just want to make sure which interface ID is being used by my LAN. Alright, so to do that, just gonna go and check to show IP interface really quick. Alright, so this show IP interface BR. I used do, okay, in Net1, Net2, I think I show you how to use this one. Okay, I put do in the beginning so that I won't need to exit from this interface. No? So the interface being used is again G00 with that IP address right there. So it's still G00. Okay, so I'm still inside OSPF, router OSPF, so I'm just going to declare passive interface gigabit internet 0/0. Enter. Alright, so we're good with R2. So I'm just going to put, I'm just going to exit. I'm going to save that. Okay. Alright, so we're done with R2. Our next configuration will be R3. So again, guys, now it's just pretty straightforward. So this will just be without me explaining different steps. Probably you can finish this in what, 2, 3, 5 minutes. So it's just few lines of configuration. So for R3, I'm just gonna make it quick, right? Router OSPF, process ID number 10. It's just the same process ID on all routers. Alright, so next, I'm gonna declare the router ID. This time I'm gonna use 3.3.3. I'm gonna declare network. Okay, so I'm just gonna move this one a bit to see the network that are directly connected this time to R3. So you have R3 here, you have three directly connected networks. You have 192.168.10, 192.168.10.8, and 192.168.10.4. So I'm going to start off with 192.168.10 subnet mask /24, that gives you 0.0.0.55 area 0. Don't forget the area 0, right? It must be the same, identical, okay, to all the interfaces that you want to participate on the OSPF. Alright, so since again, no, take note, single area uses only one area number, which is this time it is 0. Okay, enter. Okay, I'm just gonna put press up arrow key, change the values. This is 10, dot 8 slash 30, that means dot 3. All right, the other one is 10. All right, so look at that, huh? It already established adjacency to router 2. Okay, so I'm just gonna put 10.4 network here. All right, so that is dot 3 as well because uses slash 30. Notice that this one right here. All right, so area 0 as well. So when I press when I press enter here, you expect when the Ospf processes runs, okay, it will establish a adjacency with R1. Okay, so a process, if it works well, a process will pop up, okay, or a message will pop up after I press enter here, saying that R3 and R1 are already established network adjacency. Okay, so just wait for that. There you go. So you have the bridge to 1.1.1.1. So that's how important router IDs is or are. Okay, because you can see directly, no, which is the one or which router has established adjacency with that particular router you're currently working. Okay, so I guess we're done. Okay, the last procedure will be declaring the passive interfaces. So I think that is also G00. Okay, so I'm just gonna do that here, enter. Or if you're still confused, you can use always the show IP interface brief, show run, just to check if this link right here is really G00. Enter. Okay, I'm gonna go out and I'm gonna just save. Alright, copy, run, start. Alright, so enter. So yeah, I guess that's it. No? The configuration of each of these routers. Alright, so the next step, of course, is the validation. Okay, so we're gonna try and validate. Okay, if a network convergence has been achieved in that your OSPF is up and running. Okay, so but before that, okay, let me just give you a useful show command that we can use to check for the OSPF parameters. No, so the first show command, okay, can be entered using the privilege mode. Okay, you can do show IP OSPF interface brief. So she's the same with show IP interface BR, but this time we added OSPF. Okay, so when you press enter here, okay, let me just check on that. Alright, so it's this show IP OSPF interface. OSPF. Okay, I'm just gonna use bus ID 10. Okay, so to check if you have different parameters running, just check. Okay, on this particular router. So these are the parameters for this router. You have router ID. Okay, you have the adjacencies. Okay, just check show IP OSPF neighbor. Alright, write this one right here. So when you do show IP OSPF neighbor, it will show you the router IDs of the adjacent routers that has full connected state on that particular router. So in this case R1, so I have full connection to 2.2.2.2, that is R2, and 3.3.3, that is R3. Okay, so it's the same configuration. Okay, so you can use the different show IP OSPF commands, okay, to check on that. Okay, so we have this one. Okay, let me just fix it, and then just try to ping, no? Let's test if our network is working. So I'm just gonna go to PC1, and I'm gonna try and ping PC3, okay, remote network PC3. So I'm gonna go ping 192.168.1.2. That is PC3. I'm coming from PC1. Let's enter. Okay. So we have, okay, so right there. So we have, if you try that again, it's gonna be 100% successful. Okay. So I'm gonna try and ping PC2 as well. So ping 172.16.2.2. Okay, I'm coming from PC1. Oh, all right, there you go. Okay, we're just gonna try that again. All right, so successful. So it means PC1 can reach both PC3 and PC2. Okay, how about if we go to PC3? I'm just gonna ping PC2 because I know that PC1 and PC3 are already communicating. So I'm just gonna go with PC2, 172.16.2.2. Alright, so there you go. So it's just the same successful thing. Okay, so this is how we implement single area OSPF on IPv4. Alright, so yeah. Okay, on our next topology, we're just gonna try and run the basic configuration this time on an IPv6 network. Okay, and then we're just gonna see the difference in terms of OSPF implementation for V6 network. Okay. All right. So moving on with the IPv6 network. So this time we're gonna run OSPF. Okay, but this time implement OSPF single area OSPF implementation with an IPv6. As you notice now, this one is an IPv6 network. Okay, so it's the same 3 router setup. Okay, same with our topology a while ago, but this time it uses an IPv6 IP address and network addresses. Okay, so we're just gonna use the same parameters from our topology a while ago. We're gonna use process ID number 10. Okay, we're gonna declare router IDs for each of these routers. We're gonna use area 0, okay, on all routers to declare it as single area. Okay, but this time we're gonna see how IPv6 implementation of OSPF is different from IPv4. Okay, so let's just go straight to it. So I'm just gonna go to R1. Alright, so inside R1, so you notice again, no? If I'm gonna do show IPv6 interface brief here, okay, we already have IPv6 address configured, okay, on the active interfaces. So we have a G00 up and running, we have serial 00 up and running, we have serial 001 also up and running. Okay, so those are the 3 interfaces for R1. Okay, again, no, the counting for number of directly connected and the remote networks are still in effect for this topology. Okay, for this version. Same with IPv4. But this time, okay, as you will see later, no, it just differs in terms of the network declaration. In IPv4, we manually declared directly connected networks, okay, using the network command. Network 192.168.10.0, for example, along with the wildcard mask. Alright, so there are lots of things that you need to consider, okay? You should be, number one, you should be entering the correct network address. At the same time, you should have computed for the valid or correct wildcard mask. Okay, if you mistakenly entered wrong, okay, wildcard mask value, it will have a significant impact on your network. Okay, so that's why it's confusing. It's a bit confusing, no? in terms of IPv4 implementation, no? And it is prone to error. Okay, but this time, okay, we're going to see it in IPv6 totally different, but the approach is just the same. No, we're just gonna use the same we're just gonna use the same OSPF network, but this time see the difference in terms of IPv6 implementation. All right, so let's get to it. So I'm gonna go to global mode. Okay, under global mode, don't forget to start off first to declare this one. Okay, so we enable IPv6 unicast routing first. Okay, so don't forget to enter that. So we've been using this since we've learned how to use or implement or how to configure IPv6 on each interface, no? To enable unicast routing on IPv6. And then after that, okay, we're just gonna enable Ospf on this router. Okay, so to do that, the command will be, okay, in IPv4 we have router Ospf command, right? Okay, this time in IPv6, it is IPv6 router. All right, so it has IPv6 in the beginning, Ospf 10. So we're just gonna use the same process ID 10 on all routers. So what's the difference? In IPv4, you're only typing router Ospf 10. In IPv6, it is IPv6 router Ospf 10. Okay, you see the difference now. Okay, so let's disregard that message. It's okay. Next is, yeah, we're just gonna go straight. So we are inside config router command inside OSPF. So you will see the same OSPF command when you put question mark there. You have the same area, you have the same auto cost bandwidth, distance, you have your passive interfaces also there, along with the router ID declaration. Okay, so we're just gonna do just that. Router ID for R1, it will declare 1.1.1, enter. Okay, I'm gonna do passive interface as well. Just go straight. Passive interface, the one that is being used for LAN is G00 right there. So I'm just gonna put in gigabit Ethernet 0/0. Okay, so one thing that you notice, no? Let me just put question mark again. Okay, let me just maximize this so that you can see clear. All right, so which command in IPv6 OSPF do you think is missing from IPv4 OSPF command? So almost all of the commands, mostly all of the commands are here, except for one. What is that? Okay, so if you answered network, correct. Okay, you see that there. No? So we don't have network command inside IPv6 version. No? You don't see the network command. Okay, you still have the no, the negation command, but you don't see the network command. Okay, so imagine, no, in IPv4 a while ago, okay, how important network command? Yes, because that is the command that we use to declare directly connected networks inside OSPF. Okay, but in version 6, we don't have network command. So the question here is, how are we going to declare the directly connected networks for that particular router? Okay, so the answer is you don't actually declare it. Okay, inside this config router command. So once you're done with the passive interface, you distribute static. Once you're done with that, auto cost bandwidth, if it has a declaration, then you go with it. The next thing you need to do is to enable. Okay, same with the EIGRP. If you remember EIGRP, we don't declare network as well. Instead, we enable EIGRP inside inside the interface. So this time, it's just the same. So we're just going to enable OSPF along with the area number you want inside the interface. Interface where the networks are connected. Okay, so it's totally different from before. Okay, in before you're looking at the network addresses, right? In V6, IPv6, okay, the significant values are the interface IDs, because using those interface IDs, that you're going to run OSPF inside those interfaces. So you need to identify the interfaces that are being used actively by that router. Okay, so to do that, okay, I'm just gonna go back to global mode. All right, so I'm just gonna do it one by one. So I'm just gonna declare it first on this network link here, yung LAN link. So I think that is G00, right? So G00, that is the active right there. So I'm just gonna go there, no? Interface G00, enter. Okay, inside this interface, okay, this is how you include this network, okay, on the exchange of routing information update inside OSPF. So you type in IPv6, so this is the command. Take note of this one, OSPF, okay, again. Alright, it will ask for the process ID first. Alright, process ID, which is again 10 space, okay. Next, you have the area. So I'm just putting question mark to see the parameters that are needed to fill up. Area and then question mark, and then what area you wanted to use. So since we're using single area, as I mentioned, we will just be using area 0 for the single area implementation. So 0. Okay, so again, the syntax, no? Let me just repeat that. Okay, I am inside global mode a while ago. So to start off, adding networks, okay, all you have to do is to enter the interface that has the active link going to that network. So in this case, we're going to declare 3. Okay, same procedure with the counting of number of networks, but this time, we are not after the IPv6 network. We are after the active interface IDs that is being used by these networks right here. Alright? So when I checked on that a while ago, those are G00, S00, and S001. Those are the interface IDs. Okay, so I'm just going to declare OSPF inside those interfaces. So I'm going to start off with interface G00. Alright. IPv6 OSPF process ID 10, area number 0. Right there. That's it. Okay, so you don't need to type the entire network address, particularly for this one. You don't need to type the 2001 DB8 cafe 1 /64. So it's totally different in IPv6. Okay, but the principle of counting the number of networks directly connected are the same. No? I'm gonna go out. I'm gonna interface with the other link. Okay, the S00 is the link right here. Enter. I'm gonna enter the same IP OSPF command, IPv6 OSPF command. Enter. Okay, I'm gonna exit. I'm gonna interface S001. Enter. Okay, the same command, OSPF 10 area 0, enter. Right there. Okay, so yeah, that's it. So 3 steps equivalent to 3 networks that are directly connected to R1. Alright, so once we're done with that, I'm going to go out and I'm going to save the configuration. Okay, so once we're done with R1, all you have to do is to do the same procedure with R2 and R3. And then once you configure it properly, it will establish the same link. It will result to same link establishment as with IPv4 a while ago. So I'm going to go with R2. Just going to make this one real quick because we're just repeating the configuration twice. One for each router. Okay, global mode. Okay, you have the IPv6 Unicast routing. Don't forget that. Alright, and then I'm gonna run IPv6 router. Alright, IPv6 router ROM SPF, process ID number 10. Alright. Okay, and then inside that from, I'm gonna declare the router ID. This time it's gonna be 222. Okay. Okay, I'm gonna declare also the passive interface, that is G00, the link right here. Okay. Now, if you mistakenly declared S00, either one of these interfaces as passive interface, all you have to do is to put no, to negate the command. No, so for example, let's say you mistakenly declared S00 as passive interface. No, just put no in the beginning to negate the command. So no passive interface, we declare G00, enter. Okay. So once we're done with that, I'm gonna go out. Okay, I'm gonna go with the interface one by one. So interface G00, that is G00. Okay, and then I'm gonna declare uh, Ospf, so IPv6, Ospf process ID 10, area 0. So this enables the IPv6 and letting G00 join the Ospf declaration of R2. Okay, so we're done with this one. I'm gonna go out. I'm gonna go with the other interface, S000, and then I'm gonna declare also this one. Okay, area 0, we're using process ID 10, which is the same. So right there, so you should see now, same pop-up message with IPv4 a while ago, this time establishing link from R2 going to R1. So I'm gonna declare S001 as well. Alright, with this one. Okay, I'm gonna go out, copy, run, start. So it's right there, just pretty straightforward. Huh? Let me go to R3. So enable, configure terminal, IPv6 Unicast routing. Okay, then I'm gonna declare router OSPF 10, and then change the router ID to 3.8.3.3. Alright, and then declare passive interface. If you forgot to declare passive interface in the beginning, okay, you can still do it. No? You just have to go back with IPv6 router OSPF 10 prompt and then declare passive interface. Okay, just the same. Okay, I'm gonna go out. Interface, okay, that is G00 as well, no? So we're gonna declare it also inside the interfaces that are part of RT, directly connected network. So I'm gonna declare this one IPv6. Alright. OSPF 10 area, don't forget 0. Okay. Okay. Then interface, exit, interface S000 right there. Okay. Exit. Okay, there's one right there. So established. Interface S001 and then the declaration. So let's wait for a while to establish connection with the other neighbor right there. Okay, so yeah. So since we know that we're entering the correct commands, the correct values, so it is expected that OSPF is up and running. Then you will see this adjacency messages popping out. Okay, so I'm just gonna go out. I'm gonna save this one right there. Yeah. So let me just check if we have the same or we have converged network. So I'm just gonna go and copy this so that I won't be I don't need to type it. I'm gonna go to PC1 and then ping that IP address. So I'm gonna ping that address. Okay, so I'm pinging PC3, no? I'm coming from PC1. I'm pinging PC3 address. So let's check. This one is working. Yeah. So it's working right there. It's pinging. So I'm gonna ping PC2 as well. Okay, I'm just copying the IP address so that I don't need to type it. So when I put ping here, I'm just gonna put paste there. And then PC1 and PC2 are communicating as well. So we have converged network, PC1 to 2, PC1 to 3 are good. So let me just ping PC2 using PC3. So I'm still on the copy effect. So ping and paste the IP address of PC2. Then, yeah, so as we expected, we have a converged network. All right, so yeah, that's pretty much it. Okay, so if you want to check, okay, we still have the same command. Okay, this time we're just gonna add v6 now on the show commands. Now, show IP OSPF neighbor using v4. In version 3, we have show IP v6 OSPF. Okay, and then show IP v6 OSPF. Okay, if you want to check on the parameters. Okay, so you have that one right there. Alright, so I think that pretty much does it. Okay, for this module. Alright, so if you have questions, okay, you can just type in, okay, your message inside our NetAcad class. Any clarifications? Okay, I think the sample PKAs like this one are already posted, and then be ready for the instructors made packet tracer big topology exam to wrap up cycle 1 of CCNA3. Okay, so with that, okay, so I think we're done. So yeah, thanks for listening, thanks for watching. Bye bye.